Okay, good evening everyone. Okay, today I work on this Thunderbolt inverter. Actually, the MOSFET board, one of the MOSFET fried, and it affects the driver card, which is the totem pole, the discrete driver section of the inverter. This is the control card. There's the comparator, and we have under beneath we have ULN 2003, which is a Darlington output, the Darlington output transistor encapsulated in the packaged, and we have the relays for the outputs, and also inside you have an MPPT constructed inside. That is the display for the MPPT, for you to see the event of the MPPT, and that is the display for the inverter itself, for you to see the outcome of the inverter. Okay, the driver card was actually cross-checked, which is this, was actually cross-checked, and most likely once you have a fried MOSFET, it's very important that you run a check on the driver card. So the driver card was pulled out and cross-checked. All the we have PNP, NPN transistors configured for discrete driver section as a buffer between the output signal to the MOSFET. So okay, so here is the sketch for the driver card. There's the sketch for the driver card. So you have, this is the pin for the driver card to interface to the main board. And while troubleshooting the driver card, we have NP, PNP, NPN, PNP, NPN, PNP, NPN. This is the SMT number for each of the SMT transistors, in case you want to cross-check online. You have the MY equivalent to AGR, the DKR is equivalent to MY. So this is the panel number, the Q, and on the board actually when you have a component labeled Q, it means transistor. So we have the Q14, Q8, 13, 9, 6, 1, then 7, and then 2. So we have the direction how the card was actually interfaced to the system, which is under this. Okay, I think you can see there, you can see the direction, you can see the direction, right? The arrow, you can see the arrow over there. So the card was most likely what I do when the MOSFETs fried. What you need to do, even though you have the transistors having their reading in a normal value, it is still important that you replace them with a new one, because most the purpose of a transistor is to amplify it. All right, is to amplify it, and when there is a backfeed sometimes, and the backfeed could have affected the gate, which is the similar to a bipolar, which is the base, and the base won't be able to switch properly, and that will affect the signal to flow properly. And if that happened, you have the transformer on one side of the section of the MOSFET, you have it vibrating, and that means you need to go back to the start again. And so if you don't want to, if you just want to have a seamless result, it's better whenever you are troubleshooting and you have a MOSFET fried in an inverter, you have one of the MOSFET section of the inverter fried off, one of the channel. So what you do is when you are working on the driver card, it's better you replace all the transistors with a brand new one. They are just a bipolar transistor, actually. They're bipolar transistors. So this is where the signal comes in from the main control card. The signal comes from the main control card, pass through these resistors, all right, then to you know, pass through to the interface from the card. So now the system is back after a thorough check and component replacement. So here's the view. Here's the view. So you can see. Alright. So that's the frequency. We have the output to 20 volts, and the battery level is at 2%. Alright. So I've actually disengaged the MPPT while working on the inverter section. I've actually disengaged the MPPT. So thank you for staying tuned. Thank you for always watching my video. Please subscribe and like. Thank you very much. Flextronics World Tech.